let's explore the boundary-pushing discovery. Scientists at Princeton, NASA, JPL, and Spectral Sensor Solutions claim to have harvested electricity from the Earth's rotation using manganese, zinc, ferrite cylinder. Let's unpack the science, the skepticism, and what it might mean for the future of sustainable energy. What's going on here, John?
Yeah, so they claim, the Princeton University physicist team, his name's Chiba, I think, and his team, they claim to have built a device that generates electricity directly from Earth's rotation. So this is something that physicists long believed was impossible, just like a bunch of other technologies that we've covered. So their device, apparently surprisingly simple. It's a hollow cylinder made from magnetic material called manganese zinc ferrite, and it's about 1 foot long, and it's positioned at a specific angle to Earth's magnetic field. Apparently, the device produced 17 microvolt of electricity, which is less than 1/1000th the power of a hearing aid battery. But again, this is new technology. So while minuscule, it represents a potentially revolutionary breakthrough because it appears to harvest energy from the planet's spin without any moving parts, without any fuel, or any external energy source. Now, here's why this is controversial. So for over a century, physicists have known that Earth rotates through its own magnetic field. But they proved mathematically that you couldn't extract electricity from this motion. And in quotes, I say. So any electrical charge generated would immediately be canceled out by opposing forces. But apparently Chiba's team has claimed they have found a loophole using specific materials and shapes that prevent this cancellation. Now, apparently, it's not surprising, but the scientific community is deeply divided. Some physicists are calling the work convincing and remarkable, while others who tried to replicate it have failed and remain convinced the theory is wrong. The voltage is so small, it's extremely difficult to distinguish from experimental artifacts or measurement errors, right? So if this is real and scalable, it could theoretically provide us with all the electricity need that we could ever need while only slowing the planet's rotation by about 7 milliseconds per century, which is less than the natural effects of the moon gravitational pull. What do you think? Fact or fiction?
All right, so let's go back a little bit. This goes back to Faraday. Faraday says, no, this can't happen. We can't pull energy from, and so this has been kind of one of our energy laws for a long time. And then the physicists come along and say, well, we can take advantage of, if you ever seen the diagram of the Earth with that little magnetic tunnel going through it, we'll take advantage of that and produce this. And there was a paper on, it can be done. And then several scientists tried it and failed. And then they came back and said, well, it's because you're doing it wrong. You're not using, the hollow tube isn't long enough and this and that. And then they came back and tested it. So with the right stuff. So this is the first time we're hearing that it's successful. And they call these things a 0-point energy device because, it's energy from nothing. And we'll have to see, long term, if we can do more with it. Generating 17 microvolts is, not enough to charge anything, but maybe we could get this to a point where it can, sensors, external devices, what have you. But at the same time, maybe we could potentially capture the rotation of not just Earth, but some other device and use it to power Earth. Like what happens if we put stuff on the moon to capture the rotational power of the moon and build these huge things to do that rather than these small devices?
Yeah, well, my problem is that the amount of energy that was captured could be just, an anomaly, right?
Yeah.
So, I like that. I honestly like that people are always trying things and trying to push the limits and trying new ways to find energy and trying to disprove others. And that's kind of what these academics always try to do. It's always trying to one up or try to disprove someone. But I don't know enough about this, or I don't know enough I don't have enough information about this to like make a determination. I'm not an expert in this, but I like that there's potential. I hope that they can develop the technology further so they can prove that this is a viable technology, but I don't know.
Yeah, scientists forever have thought that uniform magnetic fields can't produce electricity, but now they're proven wrong, potentially. So scientific community demands independent replication. It says the cost for building a similar device for testing is just under $10,000. Several universities are expressing interest, so they welcome the scrutiny. The replication process will likely take several months to complete, so we'll have to see, right? I love where this is heading. Multiple units could be connected together to increase total power output. Arrays of hundreds or thousands of devices might generate a useful amount of electricity. This scaling approach could make the technology commercially viable. Research teams are investigating the optimal orientation for different geographical locations. The 57-degree angle works at certain latitudes, but other angles might work better elsewhere. So that could make optimization maximize power generation worldwide. So there's a lot still to come, but this is very promising.
It is, and I think maybe we can attribute this to other technologies that were developed and were dismissed back in the day. Maybe this just needs, maybe the materials he's using is the wrong material. Maybe the position is wrong. I'd be interested to see how this develops. Apparently, the cost to run this for the laboratory equipment was about $25,000. So that's interesting to note. Hopefully that doesn't deter people from trying this or trying future experiments, right?
Yeah. The device represents a new category of harvesting energy. Unlike solar panels, the need for sunlight or wind, the need for moving air, this technology works continuously. The Earth's rotation provides a constant, reliable source. So this joins other free energy technology innovation approaches like extreme enzymes that generate electricity from waste, or smart windows that harvest social electricity, solar energy, or triboelectric panels that capture power from raindrops. So we'll have to see. I love where this is going. This breakthrough could inspire research into planetary forces. Scientists might explore ways to harvest energy from Earth's magnetic field variations, tidal forces, or gravitational effects. These investigations could reveal additional energy sources. So I'm very interested in where this is going.
Yeah.
So I'd love to know what you think. Is this 0-point energy of the future, or a dream, or is this just people made this up in the lab, and since we haven't replicated, you're not even going to think about it yet? Let us know what your thoughts are. We'd love to hear them. So what do you got going on, John?
Yeah, so coming out in September, definitely gearing up for Elevate. I know you're a partner with Elevate, aren't you, Craig?
Oh yeah, absolutely. So definitely we'll be doing something during the Elevate a week, probably a Flowgrammer event, if nothing else. They're a partner of ours. Definitely go out and check it out. There's a lot of great events going on related to Elevate. That's why I said great events, sessions, program. Check out their schedule. Check out all the different lines of programs and stuff. There's always good things there. So definitely go check out Elevate. And check out Toronto Starts for our startup drinks, our startup investor drinks, and our Flowgrammer events where we help people learn how to automate things in their business. And John, if people need funding, where do they go?
Yeah, come find me on LinkedIn. I just posted some news about the Shred program, but come find me on LinkedIn, send me a message, and we'll talk and see if it makes sense to find some non-dilutive funding for you.
Really appreciate everyone taking their time to watch or listen to this week. We'll see you again soon.
Thank you.